Hello everyone, in this video we are going to see about the operations in queue along with the algorithms. Okay, let us see first of all the algorithm for insertion. We know that we have two operations in queue, namely insertion and deletion. So we also know that insertion takes place through the rear end of the queue and deletion takes place from the front end of the queue. And also we know that queue is a first in first out data structure. It's a linear data structure. Let us see the algorithm first, how to insert the element, and before that we'll see what is insertion. It is the process of adding a new item into the queue at the rear end. If the queue is full and we try to add a new item into the queue, it makes the queue overflow. That means we can insert the element only in the queue where some space is there. If the queue is full, we cannot add more elements. Let us see the algorithm. Step 1 says if front is equal to 1 and rear is equal to n, or front is equal to rear plus 1. If this is the condition, this says the queue is full. You cannot add more elements. So this condition says that the queue is in overflow condition. We cannot add more item and algorithm will return, okay, without doing anything. Because we know that front is the first, which is 1, and rear is equal to n means the last one. That means the queue is full from the front to the rear. That means from the first to the last, so the queue is full. Otherwise we can check another condition. Front is equal to rear plus 1. That means the rear is incremented to the front pointer, which is rear plus 1 is equal to front. In both the cases, if either cases occur, then it is an overflow condition. Then next step says if front is equal to null, then set front is equal to 1 and rear is equal to 1. So now first we have checked front is equal to 1 and rear is equal to n. So this condition, when it becomes false, it will come to the next step when checking whether front is equal to null. That is the case means we are having the empty queue. We have to create a new queue. So that is done by set front is equal to 1 and rear is equal to 1. Okay. Else if rear is equal to n, that means here front is not equal to 1 and rear not is equal to n means the queue is not full and also the queue is not empty. Then what you have to do? Else if rear is equal to n, then we have to set rear is equal to 1. That means if the rear has come to the last position, now the rear has to move to the first one because it works like a circular queue. Okay, and then set rear is equal to rear plus 1. So we can keep on incrementing the rear in order to add the element or insert the element in the queue. End if. Okay, so the step 3 checks for whether the queue is an empty queue, and for this empty checking of the empty queue, this checks all these conditions. Okay, and then step 3 says after you found the rear location, we have to push the data, you have to add the data into the rear position. That is done by set q is the function of rear is equal to item. So what is the item you want to add is the item. New entry is the item, and where it has to be moved, it has to move to the rear end through the rear end of the queue by the function set q. So this will add the element or insert the element into the queue through the rear end, and this algorithm stops. Okay, so these are the steps to make the insertion operation. So initially the insertion checks whether the queue is in the overflow condition, and then it checks for whether the queue is an empty condition or the queue has some data. So this is done by this step 2. If it has some data, the rear pointer is incremented to rear plus 1 to the next position, and the item is pushed to the position showed by the rear condition with the rear position. Okay, now let us see the diagram how the insertion takes place in the queue. So this is the queue initially. Just we have defined a capacity of the queue. This is in the array form. We know that we can implement the queue using either array or through the linked list. Now here we are using the array concept. Now let us assume an array of 8 size ranging from 0 to 7. So initially head is equal to tail. That means head and tail points to the same pointer. That means initially nothing is there in the queue. The queue is empty. Okay. So now if you push one element to the queue, now the head has the value, the first element, and now the tail has to be incremented to 1 because the tail always goes to the back. So once the head element is inserted, the tail positions start incrementing to the continuous positions, and now they keep on adding more elements like 27, then 19 and 17 and then 7. So now the element 27 is in the head position, which is the first position of the queue, and there are elements, there are 4 elements, and the third position, the element 7 is there. Suppose we want to add more elements, that has to be done to the rear, which is the tail position. So now the tail points to the empty position, which is 4. So now we can insertion can take place from the 4th position onwards. So this is the operation of adding the element into the queue. Let us see the same algorithm of insertion using the linked queue. We know that the queue can be implemented either through arrays or through linked list. Now this algorithm says how the linked list is implemented using the queue is implemented using the linked list and how the insertion takes place. So as usual, we have to create a new node because unless otherwise there is no node, we cannot add the element, insert the element. So we have to create a new node. Like the array concepts, there is no initial array, there is no static memory position available. We have to create a node because it is a linked list concept. We have to create a node. So that node is created using the line new pointer is equal to new node. So this new, we create a new node and it assigns to the new pointer. Then we have to add data to the new pointer node. We know that any node of the linked list consists of information and the link. Okay, information contains the item and link contains the next pointer. Since this is the first one, we are just adding the first element in the queue. We have to set the link as null because no more elements now. So how to set the pointers? New pointer arrow info. This gives the info field of the new pointer, which is item. The item we are now inserting. Then we have to set the link also. How to set the link? Initially there is no more element, so now link is null. Okay, this arrow gives that new pointer is the node and information is the field and link is the another field. So those two values are set by this line. Then you have to check whether if rear is equal to null. If rear is equal to null means you have to set the front is equal to new pointer. So rear is equal to null means there are no more element in the rear position. Rear is in the null pointer. That means you have to create a pointer and you have to assign the values for both the front and the rear, which is the new pointer. So initially one pointer is there and that pointer is equal to null means you have to create a pointer by using this statement. Front is equal to new pointer and rear is equal to new pointer. This means both the front and the rear are same, which denotes the newly created pointer. Then we have to go for the next else. What we have to do, if rear is equal to not is equal to null means we have to do rear arrow link is equal to new pointer. That means you are attaching one more pointer or one more node to the rear pointer, rear node. So rear is equal to new pointer. So we are now the link of this rear pointer points to the new pointer means we are adding the new pointer to the rear end. And then we have to set the rear is equal to new pointer. So now this algorithm will repeat again and again to add more and more new pointers, and they keep on setting the values of the information as well as the link pointer. This is how the insertion takes place in the linked list representation of queues. So initially we have to create a new node, we have to set the information and the link field of the new node, and then we have to check whether we are in whether we are having the empty node to insert the values, or we are in the in between of the linked list. That means we are having any other in between pointers. Accordingly, we have to adjust the pointer. Let us see with the example, easy to follow. Now this diagram says the linked list insertion. So we know that the insertion of the data in a linked list can happen either in the header position or intermediate or in the null position or the tail position. Now this diagram says how the insertion takes place in the intermediate position. That means here we are having the list from A to D in the linked list, existing linked list, which is a queue. Now we want to add one more element called E in between B and C. So what you have to do, first we have to assign the value of TMB to the B, and this pointer will point to the next, the new node, which is E, and this E pointer points to the C. That means in this link is cut down. You can see the mark is red, cross is there. This cross just indicates that the old link between B and C is cut, and we are adding a new link to between B and E, because E is the intermediate inserted node, and that address will point to the C node. Okay, so now in between one node is added on the insertion in between the nodes. Next is the case where we are having the insertion which is in the last position. Last position insertion is very simple. Just you have to cut down the null pointer, and that pointer should be attached to the newly creating node, and then this newly created node has no more followers now. Now it is set to null. Okay, this is the insertion at the end of the list. And let us see how to delete the values from the element of the queue. Okay, so what is deletion? Deletion is the process of removing a data from the queue from the front, because we know that from the front we can delete the elements. So we cannot delete the element from a empty queue. If you try to delete the element from the empty queue, we get the underflow condition. So what is the algorithm? Algorithm is as below. First step, we are checking if front is equal to null. If front is equal to null means then you have to say the queue is underflow. That means nothing can be removed, because front itself is null. We can remove only from the front element. Now the front itself is null, so we can say that the queue is in the underflow condition. That means nothing can be deleted and return the address. Next step says set items equal to queue of front. That means if condition becomes false, we will come to the next step. What is step 2 says? Set the item to queue of the front. So whatever the element is available in the front pointer in the queue, get that data and put it in the item, which is the removed item. Then we are checking if front is equal to rear. That means after removing the item, we are checking whether front and rear becomes same. If that is the case, then we have to set front is equal to null and rear is equal to null. That means if you are removing an element which is the only element available, or after so many deletions, if the front becomes rear means it will become a null queue. So we have to set front is equal to null and rear is equal to null. That means nothing is there in the queue. We have removed the element from the queue, all the elements from the queue. Else, if front is equal to n, then set front is equal to 1. Now the case if the front is not equal to rear and front is not equal to null means we are just checking for if front is equal to n. That means the front has come to the end of the list. That means no more space to add. If that is the case, we have to set front is equal to 1. That means this will go like a cycle. And else set front is equal to front plus 1 means otherwise you have to increment the pointer to point to the next front position to delete any element afterwards. End of. And the step 4 is to stop the value of the process. So this deletion process checks whether the queue is in the underflow form. If it is underflow, nothing can be deleted. That means if there is no element, nothing can be deleted. Then we have to set. Else you have to remove the element from the front of the queue. After removing the front element, you have to adjust the front and the rear pointer accordingly, whether the front is equal to rear or the front is equal to n or the front is equal to some other value in between. Accordingly, the front has to be adjusted because you have removed one element from the front of the queue. So this diagram says how the deletion takes place from the queue. So here we can see there are a few elements, three elements in the queue. First is 19 and the last is 7, and the tail is in the next position after the last element. Now once you remove this, we know that removal takes place in the front or the head position. So when you apply the remove operation, this first element, which is the 19, okay, so only that can be removed. So we have to, after removing, now what will happen, this head pointer will move to the next position. Now head becomes head plus 1 after removing the values. And let us see how the linked list representation of queue performs the delete operation. So what you have to do, the first step says if friend is equal to null means there is nothing in the queue is empty, we cannot remove from the empty queue. Else, that means there are some content in the queue. What you have to do, get the content which is the info from the front field, because we are deleting from the front position. So we get the data of the front field and put it in the item fill. Now by checking after removing, if front is equal to rare means we can say that front is equal to rare is equal to null. That means we are coming to the null pointer. After removing all the elements, once at one time will come to the null pointer. That is this condition. Front is equal to rare is equal to null is an empty queue. Else front is equal to front plus 1. That means we can adjust the front pointer onto the position next, so that the pointer always points to the front element, so that it is easy to delete the element from the queue. So that's all, the algorithm ends. So here deletion first checks for the underflow condition, which is queue empty. The queue is not empty, then the element which is pointed by the front pointer is deleted. After deleting, the pointer is adjusted. By adjusting the pointer, we are checking whether the pointer becomes the last one or intermediate one. Accordingly, the front pointer is incremented. So this is how the deletion takes place in the linked queue implementation. Let us see the diagram how the last node get deleted. Deleting the last node is very easy. Just we have to, okay, so this is the deletion from the head node. It is given, it's a mistake here. Deleting from the head node. So head node means we are removing the element 5, which is in the head node. After removing, the head node becomes the next one, which is the 10 becomes the head node. Now 5 is removed over here. So this is the diagram for deleting from the head node, not the last node. Okay. And the next diagram says about we are deleting from the intermediate and the front last node. Okay, so now this is intermediate node. We are removing the data which is C. So how to remove from the intermediate node? We are just to make the pointer of this B point to the D. We want to remove C. Okay, so whichever you want to remove, we remove the data and put it into temporary variable, and then we connect the pointer of this pointer to the this pointer. That means this link is cut down and it is pointed to the new, that is the consecutive next node, so that the intermediate node will be removed. The other case is deleting the last node. How to delete the last node? We have to go to the null pointer and then you have to remove it, and the null pointer will point to the previous node. So null pointer is in last data is A and it is removed now, and now the pointer null pointer, now it is, this is the null pointer. Now the null pointer is point to the pointer of V. So now V becomes the last node. So this is how the deletion takes place, either in the first, in between, or the last node. So that's all, the algorithm for both insertion and deletion using the array and the linked list concept. Hope it is easy to follow, and thanks for watching.